Right, this is just a test to practice using Debut, which is the program I'm using to record things, and it lags like hell. Right, so this video is going to be about the Trapezium Rule. It is something you need, I think it's AS Core 2, if I'm not mistaken. It is a way to estimate integrals, so as I've got down here, if you've got a function of one real variable, want to integrate between two values a and b. Usually you find an antiderivative, and then you plug in the values. However, that isn't always possible, and that is why we need the Trapezium rule. So as we see, say if the function looks like this, or something like that, and what we want to do is split the interval AB, you just see it there, into strips, and then create little trapeziums, hence the name. Then, if we can work out the area of those trapeziums, like this, then that'll provide us with an estimate for the actual integral itself. And it's fairly obvious that the more strips you use, the more accurate this will be, as far as I'm aware. So we have so far. And so obviously the area of a trapezium is a plus b over 2 times h, where a is one side and b is the other, h is the height. And so you got that. So what we do, before we had 3 strips, now we have n strips, so as many strips as you want. And so the first thing you have to do is to split the interval AB into ordinates. So these x0, x1, x2, also including xn. Now here, notice you have xi, which is a plus I lots of b minus a over n. So those are your ordinates, and then the y's are just the function evaluated at those ordinates, as you see on the diagram. And then that gives you these trapeziums. Now you'll know that assuming you've split it so that the strips all have the same width, and the question will expect you to do that, then the width is given by b minus a over n, and therefore your estimate should be the following: y0 plus y1 over 2 lots of h plus y1 plus y2 over 2 lots of h, up to and including yn minus 1 plus yn over 2 lots of h, which simplifies to this thing here, which simplifies to this thing here. The eagle-eyed amongst you will notice there's a bit of an erratum. That should say yn minus 1 at the very end, not yn. I'm very sorry about that, but it's quite hard to edit it after the fact. But it's also in your formula book, so don't forget that. And here are the likely problems. You've got insufficient degree of accuracy. So for example, if the question asks you for, say, 3 decimal places in your accuracy, make sure in your intermediate steps you use maybe 4 or 5. In some calculators you can actually plug the entire thing in on one line, so just do it all in one step. But that's kind of putting all your eggs in one basket, because if you make even the slightest error in one part, then it will throw off your answer. Which kind of gives to my second point here, general calculator error. So yeah, be very careful. It helps if you show you're working, because you get follow-through marks, in the sense that if you actually explicitly state your x values and your y values, if you use them correctly within the formula, you'll still get the marks. Big one. If the function involved is a trigonometric function, so sine, cosine, tan, secant, and inverse sine, etc., always make sure you calculate with septaradians, or you'll get the answer wrong. This one, not as common, but I can imagine some people might do this. Confusion between number of strips and number of ordinates. The way I've denoted this, n is the number of strips, therefore you'd have n plus 1 ordinates. So for example, if the question asks you to use 5 ordinates, whatever you do, don't use 5 strips, because then you'll get a different answer. I'm not sure how harshly you'd be punished for that, but I'm assuming it would be classed as wrong. Right, extension of the idea. Define in as the value of the estimate when n strips are used. That's fair. And then that will give you a sequence of real numbers. And so assuming it has a limit, and you can find it, then that will give you the exact value of the integral. One little thing though, it's a lot easier, instead of using trapeziums for this, to use rectangles, what we call step functions. These are functions where if you split the interval into strips, it is constant, the function on each strip. Therefore the area under it would just be a series of rectangles, so that's much easier to evaluate and much quicker. Anyway, that's an extension of the idea. That isn't needed for A level, but if you're interested, that is one way you can evaluate an integral if you don't necessarily know the antiderivative of the function. Anyway, that's all.